Assalamu alaikum. Today I am going to some other topics of fundamental group. One proposition we have: let X be a path connected topological space. Then for all x naught, x1, for all x belongs to X, some axis x naught, x1 belongs to X. So the first fundamental group of X, base point x naught is isomorphic to the first fundamental group of X, x1. So what is path connected topological space? Let's say X is a path connected topological space. So there exists a function, continuous function from open interval, from unit interval, close unit interval to topological space, such that f of 0 is equal to x naught. X naught is the initial point of this path, and f of 1 is equal to x1. X1 is the final point, terminal point of path. So x naught here, x1 here. So according to the proposition, if X is the path connected topological space, path connect means that every 2 points in this space we have a path continuous function such as like f from I to x, such that f of 0 is equal to x naught, means this is x naught, and f of 1 is equal to x1. So we can make a path from one point to another point. So we can say this X is called path connected space. So according to the proposition, let X be a path connected space, topological space, then the first fundamental group of X naught is isomorphic to first fundamental group of X1. Now we are going to prove this proposition. Since X is a path connected space, therefore x naught, x1 belongs to X, there exists a continuous map H I from X, I to X, means H is a continuous map from I to X, such that H of 0 is equal to x naught and H of 1 is equal to x1. And define a map beta H, define a map, we define another map beta cap, or we can say beta H. Beta H is the map from first fundamental group of X, x naught to first fundamental group of X, base point x1. And how can this work? If we substitute a map, if we substitute a loop of this fundamental group, so this is how this is work: h bar f then h, means this is x naught, and this is x1, and this is the path from x naught to x1 is h, and the reverse path is h bar. So beta cap is the map from first fundamental group of x, x naught to first fundamental group of x, x1. And the equation of this, if we substituted a loop from x naught, so we will get h bar. Homotopy classes of this: h bar concatenation f concatenation h, means starting from first we apply h bar starting from x1, this is x1, this is x naught, this is h bar, and this is h. So first we apply h bar means x1 to x1 to x1 to x0, then a loop f is a loop here, then h, so x1. So if we substituted a loop from this, we will get a loop here, means this is the loop at base point x1, because starting from h bar starting from x1 to x0, then f loop x0, x0 to x0, then h is a path from x0 to x1. So starting from x1 to end at x1, so this is the loop at base point x1. So here we have sorry, this is wrong. Note that beta h is well defined for it if where f the path homotopy classes of f is equal to the path homotopy classes of g, which means that f is homotopy or homotopy to g, or we can say, if this hold, then we can say h bar concatenation f concatenation h is homotopic to path homotopic or homotopic to h bar concatenation g loop concatenation h. This is both are homotopic. Further implies that the path homotopy classes are equal. So implies that beta cap of f is equal to beta cap of g, because f and g both are homotopic. So we can say beta cap is a homomorphism, since if f and g are isomorphic homotopy class, we are defining how can we define homomorphism. So beta cap of f dot g is equal to beta cap of, according to the condition of well defining loops f static g. So according to the definition, first we apply h bar, then f, then g, then h. So here we can see first h bar starting from x1 to x0, this is h bar, then f is a loop around x0, then g is also a loop around base point x0, then h. If we replace this cx0 h, so what is the effect of this g? If we add this constant loop x at x0, so this is not further change in this in equation, because first h bar, then f, then stay here, cx0 means constant loop, stay here, then g, and then h. So we can say cx0 is h h static h bar, because c naught is equal to h static h bar. How can we claim this is equal? Because c naught is stay at x naught. So this is the definition, this is the equation is like first from x naught to x1 h, then h bar again, and at x naught, starting from x naught to and at x naught. So we can replace cx naught to h static h bar. So if we replace h bar, then f, then uh, in the place of cx naught we will replace h, then h bar, then g, then h. So we can see this is beta cap of f, and here we can see this is as like beta cap of g. So this is the homomorphism of steric G. So this is proved homomorphism. Now we are going to explain isomorphism between this. Now I am going to explain isomorphism. As we know, beta cap is a map from first fundamental group of x, x naught to first fundamental group from x, x1. Let alpha cap is the inverse of beta cap. If alpha cap is the inverse of beta cap, then alpha is inverse of beta, means beta bar is equal to alpha and alpha is equal to beta bar. This is condition. We will use this conditions. So let's say K is the loop in first fundamental group of x1. Means K is here loop at first fundamental group of x1. Loop at x1. So if we substitute first loop, if we substitute this loop at alpha bar, and we know that alpha cap is the loop, alpha cap is the map from first fundamental group of inverse of beta, so x1 to x0, first fundamental group of x0. So we know that. So if we substituted k loop in this map, in this function, so we will get alpha bar concatenation k, the concatenation alpha. As we know that alpha bar is equal to beta, so we will change alpha bar is equal to beta static k static beta bar. So if we substituted the condition of inverse, the composition of beta bar compose alpha bar, then substituted k. So according to this condition, alpha bar concatenation k concatenation alpha, and according to this condition beta bar, then beta. Then we will replace alpha bar with beta. So alpha bar with beta, and here is alpha, and alpha replaced with beta bar. So beta with beta bar is constant map, is identity. Then here is also identity. Then we will get k. Similarly, if we compose these alpha cap compose beta cap of k1, we will get k1. So this is the condition of isomorphism, because inverses exist in this condition. So we can say this proposition, since according to this proposition, if x is path connected topological space, then we can say that this is every fundamental group of every point is isomorphic to another fundamental group of another point. Means first fundamental group base point at x0 is isomorphic to first fundamental group base point at x1. Thank you. Allah Hafiz.